All right, today we are going to look at the applications of derivatives, but with word problems. So this is going to involve looking at the difference between original functions and first derivatives. When do we want to use which one? These questions are not going to specifically say, use the original function. They're going to use things like find the population, find the rate of change of population. So the original function will be based on whatever the function has told you it is for, and the first derivative is usually looking for change. So that's kind of the key to this. Okay, so let's read this. The population of a city grows from 100,000 to a size p. So p is representing a number given, by P of t equals 100,000 plus 2,000 t squared, where t is years. So let's note that we're talking about P of t. Usually we're dealing with f of x, but today we're going to deal with P of t. That's fine. It just means that we're dealing with the population with respect to time. Okay, so it says find the growth rate pt or dp dt. Now remember, usually we would write dx dy. That's when we're talking about functions that have x's and y's, but we have functions right now with p's and t's. So dp dt is just the derivative. We can use any letters we want for that. So we're going to see that coming up. So we're just looking for the derivative. And that is and it's telling us that the derivative is the growth rate. So it's not the actual number of people that live in the city, it's how many that grew by. So that's great if you have 120,000 people, but did you grow by 10,000? Did you decline by 3,000? So this formula that we're going to find is going to tell us about the growth rate. So to do that, we're going to take our original function and we're going to find the derivative. The derivative is going to be p prime of t. The derivative of 100,000 is nothing. The derivative of 2,000 t squared is 4,000 t. Okay, find the population after 10 years. So you have to really pay attention to what it's asking. Find the population. Is it asking you how much the population changed by? No, it just wants the population. That's going to come from the original function because it said the population of a city is given by P of t. It's telling you the original function is where this is at. So after 10 years, so we're going to come up here and we're going to find P of 10. So we're just going to plug 10 into this and see what we get. So if we plug all that in, what's our answer? So we get 300,000. So our population after 10 years is 300,000. All right, find the growth rate. Find the growth rate. Growth rate is our key word here. The growth rate at 10 years. Is it increasing or decreasing? So I know how many people there are. The population is how many people. Now I want the growth rate. Well, clearly using the original function is not going to tell me. So the growth rate, remember, we defined is using the derivative. So I'm going to use this function to tell me about growth rate. So the growth rate, so P prime of t, and my t is going to be 10 years. So P prime of 10 is going to be 4,000 times 10. Which of course is 40,000. So the city grew by 40,000 people. Is it increasing or decreasing? Well, is this a positive number? this is positive. This is a positive value, so therefore the rate is increasing. If your growth rate or your rate of change is negative, it's decreasing. So positive means it's an increasing rate, and negative is a decreasing rate. So therefore this is positive. Okay, is the population increasing at a faster rate after 12 years? So to figure that out, we would have to just do the same thing, but with 12. So we would find P prime of 12, 4,000 times 12, which is 48,000. So this is faster. This is a faster rate than 10 years. And just to be really clear, like it's very obvious here. Obviously, if you grow by 40,000 people one year and 48,000 people the next, yes, that's a higher rate. But the reason that's higher is because the slope, remember, this is all about slope on a graph. The slope is steeper. So you can look graphically at something and find where the rate is increasing at a faster pace by finding the steepest slope. Okay, so let's try another one. The average price of a hockey ticket in dollars for an NHL game after game X years after 1990 can be estimated by the function p of x equals 9.41 minus 0.19x plus 0.09x squared. So this time we've got a p, it's lowercase, it stands for price, I assume, and we're looking for X years after 1990. So if we're talking about 1995, then X is 5. So be careful of the wording. Okay, find the rate of change of the average ticket with respect to the year dp dx. So here's that funny notation again. This is telling you to find the derivative, but note the words it uses to explain what the derivative is. The rate of change of the average ticket. So did the ticket price go up by $1? Did it go up by $4? Okay, so we're just going to take the derivative. So we're going to find dp dx, which is just the derivative of that guy. So the derivative of 9.410, the derivative of 0.19x is negative 0.19, plus the derivative of 0.09x squared is going to be 0.18x. Okay, there's a derivative. All right, next question. What is the average ticket price in 2007? Now, what are we looking for here? The ticket price. So do I need the derivative or do I need the original function? Let's go back. The derivative tells me the rate of change of the average ticket. Not interested. The average price of a ticket is the original function. So I want the average ticket price. So I'm going to use my original function here because it tells me about price. So P of X, now what is my X? The average ticket price in 07. Well, this is from 1990. So how many years passed between 90 and 2007? 17. So we're going to find P of 17. So 9.41 minus 0.19. Plug in my 17 plus 0.09. 17 squared. All right, so after 17 years, the price of a ticket is what? $32.19. Sounds like an average team. I don't know. Does that sound right? I've never been to a hockey game. Okay, so this is telling us the average price in 2007. All right, now, I don't know if that price got higher or lower? Like, has the price of tickets been dropping or has it been increasing? My guess is increasing because of inflation, but I don't know. Maybe hockey's really fallen off since the 80s. Okay, what is the rate of change of the average ticket in 2000? Is it increasing or decreasing? All right, it's asking again for rate of change of the ticket price. That's going to take us to our derivative. So we're going to use P prime. We're still dealing with 2007, so that's 17 years. So P prime of 17, and we're going to plug our 17 in to our derivative. And what do we get? Crunch some numbers. Survey says 287. So the price increased by 287. It's a positive 287. So therefore, the rate is increasing. Hockey must be doing well if the ticket prices are going up. Okay, so let's recap. When you read these, you need to very carefully pay attention to the words in the problem because they are going to tell you what the original function finds. If your question is asking for some sort of change or how fast something's changing or how fast something's increasing or decreasing, that means you're going to need to use the derivative. Remember, derivatives are all about rate of change. So the words are important. You can find the derivatives of some of these crazy numbers. It's not a big deal. Be very careful to read the problem. Okay, you got this.